arcs, explodes, and blisters steel. It's used to make 50% of all products, and it puts the power to build a skyscraper in a man's hands. By friction or robot, even underwater. These are the tools that the world can't live without. Now, welding on Modern Marvels. Which load, position, and weld more than 240 component parts.
Most of the robots that are used for welding are actually used for spot welding. And probably 60% of the welding robots that are out there are actually spot welding robots.
This particular unit is a pneumatic operated spot welding system. It's got a 75 kVA transformer back here. The electrodes up here are all water cooled. This particular setup here probably runs about 10 to 12,000 amps through these electrodes right here. It's not uncommon to see 40, 50,000 amps run through the electrodes.
Given that most houses run on less than 200 amps, that's a lot of power. But it's not the only factor in a reliable spot weld. You need pressure. When the two electrodes come together, they pinch the two metal sheets at the spot and cause a small indentation in both. A robot can make a series of spot welds in a relatively short period of time. For a man, it's a heavier task.
A typical spot welding gun might weigh anywhere from 100 pounds to 200 pounds. That's a lot of physical labor to move a spot welding gun. And so a robot that's designed to handle that kind of weight is an ideal setup because the robot can just handle the spot welding gun and consistently put it in the same place every time.
Factor in the sheer number of spot welds required to assemble a car, and robots make an incredibly practical solution for car manufacturers. And advances in recent technology allow robots to reach further, work closer together, and execute a greater variety of welds than ever before.
The robot can pretty much weld the same speed as a man. Where the payoff is the robot is always welding. A man has to weld and then lift his hood up and adjust the part and put the hood back down and re-weld again. Where the robot's just going to weld, weld, weld. It might have a 85% arc time compared to a manual of 20%.
It took a man about 3 hours to make this particular product. Now that the robot's welding it, it takes essentially about a half an hour to weld the entire part.
But today, robots aren't just spot welders. Here at RobotWorx, a leader in robot system integration, robots execute nearly every form of welding, and often in surprising ways.
This system has the capability of running at about 30 to 40 inches per minute of weld. This system is unique in that there's two technologies that are actually integrated into it. One called touch sensing, another called seam tracking. What touch sensing allows the robot to do is actually find the seam. It would come down, sense that it has touched the part in one specific spot, record that data, save that positional data. It would then come up, sense the next spot doing the same process. And at that point in time, the robot would know from the trigonometry where that seam starts. There's another technology called seam tracking. What that allows you to do is once the robot has found the seam, it actually allows the robot to stay within the seam throughout the course of the weldment.
But even as robots become more sophisticated and commonplace, they will still require HMI, human-machine interface. After all, someone still needs to program them, and he or she better know welding.
For the programmer, we always suggest to take a guy that's a good welder because he's going to know, like if he hears an arc and it's not right, he'll know that it might be because of the shielding gas or the stick out the robot's using because he knows welding. But a guy that doesn't know welding might think it's because of the robot controller or something to do with the robot. Somebody that understands the process is the best kind of a robot operator programmer.
Think robots are innovative? Well, you haven't seen